Hello everyone. We're gonna be doing some more TypeScript today. Just getting set up. I was away from home, so I couldn't stream the other day. Sorry, I didn't sleep well, but the show must go on. We need to learn some more of this stuff today. Let me make sure all of the streaming things are working. I think my brain's a little slow today. I got like 3 or 4 hours of sleep, so it's kind of annoying. Alright, come on PeerTube, you can show me what's going on. Yep, it's working here. Let's pop out chat so I can easily see this. PeerTube chat's good to go. And where do I have the rest of chat? Alright, Twitch is good to go. And lastly, YouTube. Alright, YouTube's working also. Perfect. Now I just need to find chat so I can actually see you guys. Chat. View. Chat. Yep, there we go. Chat's here. Now we can go. Alright, so where have we been? Where did we go? We have done this basic stuff, everyday types, narrowing, functions, and I think we're in the middle of object types. Well, let's see, where were we? There were object optional properties. We learned about that, and I think it can mean it can be undefined. Yeah, here, number or undefined. And then you can give it default values. And then there was this thing about excess properties. Render shape, did you mean shape? Oh right, this is just saying like you can't give type definition when you destructure. No, it's destructure or here it says deconstructing pattern and here it says destructuring pattern. So destructuring, no, they're the same word. Destructuring. I just call it pattern matching, but it's not really that. And we learned about read-only properties. There were gotchas about read-only properties because you can basically, it doesn't handle things that are like sub-properties. And you can always assign it to a different like type that is, what do you call that? Type compatible, but is not read-only. So read-only doesn't change compatibility of types. That's what it really means. And so you can change it and then mutate things that are read-only. That was tricky. And someone on stream mentioned that like you can use object.freeze. That seems like a good option if you don't want it to change. Yeah. So if you really want read-only, you can do like a const variable and then all the stuff underneath it read-only all the way down. That could be something to do. Index signatures, I had a hard time grokking. It was basically like, oh, you guys, I didn't switch the fucking screen. All right. Let's do this. There we go. Index signatures, I had a hard time kind of understanding index signatures because, I don't know, it's kind of like a map, a dictionary. They all return the same type signature, so there's that. And you basically give it, I guess it's called index signature because you're giving it the type signature for the index. That's how I should think about it. And that does simplify things a lot. So you're basically you're basically saying, hey, I can use the index operator on this thing, and when I do, this is what the type signature for the thing I'm indexing is. It's a number, and it's going to return a string. It was kind of a shitty example because it didn't tell us like how to actually create one of these, but it's really simple. You just like create an object that has let me see, I think we have it in our gist. Why are we here? TypeScript. And then we have one for guards, functions, rest, parameters, objects. We must be in objects, right? Interface. Here's a square config. Config square config, and here is basically create square config. So here we're passing in the square config. I still feel like I suck at this. Here is an index signature, age book, I made one. Takes in an index that is a string, and it's going to return a number. And then we have get age, which takes in an age book and the name we care about. And we can just like call age book name because we are basically saying it does have this, whatever you're calling it, index, these brackets. And then here I'm creating one where, yeah, I guess you don't define it. You just basically make sure that everything that you return is this type number. So 30, 25, 11. And the key is a string. And then you have an age, that's a number, so that's separate. But they both have to be the same thing, I think. Right? You can't have two different return types. If you do, you have to make it a union. Yeah, for some reason this just doesn't stick in my head. So in here, what was I doing here? We're saying here's an interface. Notice we can return a string or a number. So here with the index thing, we're saying it can return a string or a number. And since this is optional, it can be undefined also. So when we are using a square config, let's see, it's called config. Type is config.opacity equals number. Ah, right, because we don't know if the config has it. I guess that's the other thing. It has the brackets, but you can use the dot operator on it also, just just like a thing. It's an open-ended type with one required predefined type. Yeah, it seems so simple, but like it just doesn't stick in my head. Yeah, this one is open-ended also. Like all of the, anytime you have a index signature, it's going to be open-ended, right? Because it could return, you don't know what the index is going to be. It could be anything. Maybe I should just keep writing them. What a pain in the ass. No, let's keep moving on, right? I think we're good here. We learned that. Did we learn? I think we're up to extending types. I think that's where we're at. Right, with two optional predefined properties. Yes, that makes sense. Extending types. Let's continue on. Extending types. It's very common to have types that might be more specific versions of other types. For example, we might have a basic address type that describes, oh, and hello, Blastoderm. I didn't say hi. I'm so sorry. Hello. Um, it's pretty common to have types that might be more specific versions of other types. More specific versions of other types. For example, we might have a basic address type that describes the fields necessary for sending letters and packages in the US. Okay, here's a basic address. In some situations, that's enough, but addresses often have a unit number associated with them if the building at an address has multiple units. We can describe an address with unit. Wow, I haven't, yeah, okay, we'll just go on. So address with unit basically has all the same things, street, city, country, postal code, but it also adds a unit. This does the job, but the downside here is that we had to repeat all the other fields from basic address when our changes were purely additive. Instead, we can extend the original basic address type and just add the new fields that are unique to address with unit. So in our thing, we can have an interface called like, let's call it a mob. And mob has an ID, which is a string. And it also has a position. I want to say integer here. It seems kind of stupid to be like number. Okay, it has a string ID, a position. Yeah. And let's give it something optional. What's an optional thing that mobs might have? Oh, I can't think of any. Let's just call it alignment. Oh, that's kind of lame. Maybe they have experience that's optional. That's how you say it, right? Experience question mark. That's how much XP that gives. All right. Um, no, types can be extended. Where was it? Do we have it here? No. Maybe here in basics. No. Was it here? Yeah, here. So you can, why does it like, stop. Okay. Extending a type, you put this like thing here, ampersand, and then it can be extended. So extending a type via intersections. The thing you can do with interfaces is that you can basically add or modify an interface with the same name without extending it, whereas with a type you cannot. So you can still do the same thing, like the code is exactly the same here. They're both bears. Yeah, but this is extending. So let's go back here. Object types. I think I made the screen too. Maybe this is easier to see. Alright, so we're here and we want interface player extends mob and a player. What's special about a player? What do players have that mobs don't have? Whew. Let's say they belong to a guild. Or they can belong to a guild, right? We don't know if they belong to a guild. So then if I join guild, we pass in a player and a guild name. Right, player. So we can do player.guild equals guild name. This works, right? But we want to check maybe if the guild is already there. So if I just do player.guild, like this is either a string or undefined, right? It could already exist. So I'm basically saying if it's a string, which means it's not undefined, right? Then we don't change it. Otherwise, we return the new player. Right, you have to use the AND operator, or I guess intersection. We haven't gone to that, I don't think, but let player equals and they would have basically an ID. We'll call him Frank. And he needs a position. His position will be 0, 0. And player extends mob, so we don't need to give mob or XP, but we don't even need to give it a guild. Then we can say join guild, our player. We'll actually just call him Frank. No, we'll call him player. And what's a good guild name? Anyone have a good guild name? Fantasy guild. Phoenix? Phoenix Ashes. Alright, let's try running this. So you can see he's been added to Phoenix Ashes. But if he's already in a guild, I'm making sure that it's not undefined. We'll see in a second, right? So, checking of string. Right here. So, guild, he's in the bandits. Now when I run this, he's still in the bandits, you see, because type of is a string. Therefore, he can't join, and this is basically like, you are not player, cannot join another guild if they are already in one. You see? So that's what this string check is doing. We could switch it the other way and say if undefined, then do this. Either way kind of works. Yeah. All right. Was I doing anything? Yeah, I just wanted to test that I understood like extends, and there we go. We have our version of basic address. That's maybe you kind of see this fantasy RPG theme that we've been doing. All right. The extend keywords on an interface. Ugh. I want like a soda. You can tell I'm really slow today, right? Allows us to effectively copy members from other named types and add whatever new members we want. This can be useful for cutting down the amount of type declaration boilerplate we have to write, and for signaling intent that several different declarations of the same property might be related. For example, address with unit didn't need to repeat the street property because street originates from basic address. A reader will know that the two types are related in some way. Interfaces can also extend from multiple types. Oh my god, we can have multiple inheritance on interfaces. What a pain in the ass. So this is basically a union of these two interfaces, and it doesn't add anything, right? But I assume like interface like let's call it furniture. And furniture, it should have a position, right? So let's say it extends. Let's say it extends mob. Yeah, it's still extends mob, except that it's gonna have like a size. Let's say it has an area, or let's say length. We'll make it easy for now. And then we can have like, do you guys know what a mimic is? So we'll have it, we'll make our own mimic type, even though it's kind of a monster. So we can say extends mob, comma, furniture, because it's like, we'll call it monster furniture, monster chest. So it's like, those are mimics and stuff like that. And it has everything that a mob has and a furniture. It can be empty for now. So then when we say let my mimic is equal to, so now I guess it's going to make me kind of fill out everything that a mob has, right? Something like this. Position, so we'll call this mimic. And it's a monster chest, so it doesn't need a guild. But it does need, let's see what else it needs. Length and width. So now this mimic is a legit mimic. But if we can actually add something in here, right? Should I be using const in general? I guess so. With our player, we want to use let because we're the player. Isn't the player? I guess the player is. This is still valid, even though we're calling join guild because we're not reassigning player, but we are mutating player. That's so weird. But we can add something into the chest, right? Like stealth. And now we have to add something like this. All right, that makes a lot of sense. I get it. Hey Findus, how are you? Intersection types. Yeah, it's so weird, like, I have to get used to what const means in here. Intersection types. Interfaces allowed us to build up new types from other types by extending them. TypeScript provides another construct called intersection types that is mainly used to combine existing object types. An intersection type is defined using the ampersand operator. Interface color, interface colorful, interface circle, type equals. Oh, that's what this means. Here we've intersected colorful and circle to produce a new type that has all the members of colorful and circle. It's funny to call this intersect because doesn't it mean it should have the intersection, like the things in common? Isn't that what intersect means? Like, it just doesn't make much sense. We should be calling this like the union operator or whatever, right? Um, all right. I get it. Yeah, union is that. So wouldn't you want to use that here? Because it's basically extending, it's unioning this and that. You're not intersecting the two. If you intersect these two, it basically means you have nothing. Right? It's kind of weird. We just looked at two ways to combine types which are similar but are actually subtly different. With interfaces, we could use an extends clause to extend from other types, and we're able to do something similar with intersections name the result with a type alias. The principal difference between the two is how conflicts are handled, and that difference is typically one of the main reasons why you'd pick one over the other between an interface and a type alias of an intersection type. Let me close some of these windows. Does this make sense to everyone so far? All right. If interfaces are defined with the same name, TypeScript will attempt to merge them if the properties are compatible. Right. Interfaces, you can basically modify them and add new properties. If the properties are not compatible, i.e. they have the same property name but different types, TypeScript will raise an error, right? You can't change it, right? Here's an example of code that won't work because you're basically trying to change what name is, but you could add something new like ID or whatever, height. In the case of intersection types, properties with different types will be merged automatically. When the type is used later, TypeScript will expect the property to satisfy both types simultaneously, which may produce unexpected results. All right. In contrast, the following code will compile, but it results in a never type because you have personal and you have person2, and you try to intersect the two, but they have different types for the same property name. And so type staff. So when you make staffer, you get a never it's a never type here because we can't actually access name. Which is interesting because I'm guessing the rest of it still is accessible. So you could actually do this as long as the thing that they conflict on, you don't actually ever have to use. Let's imagine a box type that can contain any value, string, number, giraffes, whatever. All right, so we're using the anything. It's a box. Right now, the contents property is typed as any, which works but can lead to accidents down the line. We could instead use, I mean, you kind of want to use generics here, right? You would think if you're going to make something like a box, you make a box of something. We could instead use unknown, but that would mean that in cases where we already know the types of contents, we need to do precautionary checks or use error-prone type assertions. So here contents are unknown. We make a box with the contents hello world, and then we can check, oh, is it a string? Then we do like this stuff. Or we can use an assertion, but we risk this assertion failing. One type-safe approach would be to instead scaffold out different box types for every type of contents. Why would you do this? But that means we'll have to create different functions or overloads of functions to operate on these types. Set contents, box string, new contents, number. So we're just switching here string, number, boolean, right? And we have to make the accordingly correct type there. But what a pain in the ass that is. That's a lot of boilerplate. Yeah, so here you see they're going to use generics. Oh, we're at the generic type option. That's why we're doing this. When did we switch there? Ah, here, I just didn't even see. I didn't even look. Where are overloads? We haven't seen those, have we? Do you mean these things? All right. Where are we? You might read this as a box of type is something whose contents have type. Later on, we refer to box, we have to give a type argument. Yeah, we've seen this before. Think of box as a template for a real type where type is a placeholder that will get replaced with some other type. When TypeScript sees box string, it will replace every instance of type in box type with string. This is what C++ and JavaScript and a lot of these languages kind of have. And end up working with something like content string. In other words, box string and our earlier string box work identically. Yeah, these are the same thing. We have box A here, that is a box generic type string. And we have a box B, that is a string box, that is a box string. I wonder if these two types, I'm assuming they're compatible. You think these are compatible? Function, what can we do with a box? Delete content. I guess not. What? Oh, they're not. Yeah. Oh, you guessed that they're not the same. Yeah, I wonder though, right? Because if you say this thing takes in a box string, right? So here's our box, and it's a box string. And then it's basically going to do box.contents equals so it's going to delete your content in that sense. And then we pass in so let's console.log box A, right? We don't need this here, and we don't need this here. So this is going to print hello. So there it goes, hello. And then after, we're going to call delete content box A. And then we'll log it again. And we'll say after Is that correct syntax? I think so. There we go. Before hello, after it doesn't have anything. Or maybe we should just print it again, just like normal, just in case there's anything weird about this. There, let's just do it this way. We'll clear it. It's going to print it twice. Hello, and here's content. It's empty, right? Well, here what I was going to do was now try to pass box B into delete content and see if this is compatible. And it is. Because in the end of the day, they look the same. So let's get rid of logging this. We'll print box B afterwards. So it's going to say world. And then after we do that, it's going to be empty. So here's world, and then it's empty. So box string is type compatible with string box. Yeah, those, I see no reason why they wouldn't. This one, I think it'll accept. And then obviously the other one, that works too. So generics really are just syntactical sugar. They become the thing. They basically get erased into whatever the generic type substitution is, and they're type compatible. Right, so we can use generic functions here. Is there another generic function that we can think of that relate two types together? Well, whatever. Like, that's how we have generic functions. No, I don't think it's a deep analysis at all. What's happening is after you give it this, after you have this here and you make this, it's just basically erasing this, right? And then it makes it a type, probably like just a type name that it adds, whatever. And then this one is basically content is string in here. And then it then looks exactly like this one. So this whole type thing just goes away. It just basically becomes interface something, and then this becomes string. And then here it knows these two things are the same because even though the names are different, the actual body is the same. I think. No, but that doesn't mean it knows. Just because the IDE knows doesn't mean that in the runtime it knows. The IDE is going to try to like help you understand things, but in the runtime it doesn't know any of that. And I guess for type checking purposes, like, so here it's box string A. Yeah. I think for type compatibility, it just erases this thing. I don't think there's ever a time where like a literal version where it's instantiated is going to be different from you having typed that in and hard code it. But it is. Like we've just shown that at least in that case it is. Like it may be able to tell us that information, but I don't think it's ever going to treat it differently. All right. Well, that's what I think. Um, it's worth noting that type aliases can also be generic. We could have defined our new box type interface, which was this, by using a type alias instead. Okay, that's cool to know. Since type aliases, unlike interfaces, can describe more than just object types, we can use them to write other kinds of generic helper types. Oh, this is really neat. Yeah, so we're just showing that we can use generic types, type aliases, to make types, generic types that are not object-based. So this could be a string or something like that. That's really cool. The array type. Generic object types are often some sort of container type that work independently of the type of elements they contain. It's ideal for data structures to work this way so that they're reusable across different data types. Box string has structure compatibility with box string, but still the variable box A will continue being and not box string. Sure, but what I guess the question there is like, will that ever make a difference? And if it never makes a difference, then it's just like the fact that the IDE is helping you understand that. But if they're used in every single way, like you can use them the same way, then functionally they're the same thing, right? You never have to treat them differently. The array type. It turns out we've been working with a type just like that throughout this handbook, the array type. Whenever we write out types like number brackets or string brackets, it's really just a shorthand for array number and array string. Yep, so here we go. We see this. Much like the box type above, array itself is a generic type. Yes. So length is a number. Pop is going to give you possibly undefined or the element that it's returning, that it's an array of. And push takes in a bunch of items. It can be, it's using its own, it's kind of like a recursive definition here because this function is actually an array also. It's taking an array also. So it's kind of funny. Modern JavaScript also provides other data structures which are generic, like map, key value, set, type, and promise t. All this really means that because of how map, set, and promise behave, they can work with any sets of types. You're seeing a DTS. We can write a DTS file to write types for JS code. I don't know what that means. I don't know what a d.ts file is. The read-only array type. The read-only array is a special type that describes arrays that shouldn't be changed. I see. So we can, here's a read-only array that's from a string type. We can read values, but we can't mutate values. Okay. Much like the read-only modifier for properties, it's mainly a tool we can use for intent, right? Because you can kind of bypass it. When we see a function that returns read-only arrays, it tells us we're not meant to change the content at all. And when we see a function that consumes read-only arrays, it tells us that we can pass any array into that function without worrying that it will change its content. Unlike array, there isn't a read-only array constructor that we can use. Instead, we can assign regular array to read-only arrays. There we go. D.ts files, is that a coding style thing? Or is that like you're not allowed to put anything else in a d.ts file? Just as TypeScript provides a shorthand for array type with type, bracket bracket, it provides a shorthand syntax for read-only array type with read-only type. Alright. That makes a lot of sense. Let's try that out. So I can have like an array of, what happened to all my other stuff? Oh, this is my other one. Let's have an array of mobs. So we make a bestiary here, which is an array of, I guess mobs. And we can just, I think we can just put it in one line. Where's our mob? We made a mob, right? We have no mobs. Let's make a mob. A wolf is a good mob. Mobs have ID, position, and XP. They give 10 XP. Alright, so now we have a wolf. We'll just make a whole bunch of wolves. Oh, did we get like some spam? Does that erase it from Twitch also? Maybe it doesn't erase it. Not very good at like, what does this do? God damn it. I click on the user and I can click span. All right. Oh, this stuff you're talking about, the DTS here, it puts all the stuff in there. Yeah, I know. These are all the types from TypeScript is what you're saying. Hey, Satoru. Ça va, chérie? Do you need anything? Okay, what was I doing here? I was making an array, right? And then obviously like if I make a function that takes in one of these things, like function, what do we do with the bestiary? Like it is, so what is this called? Is it called read-only array? Read-only array, right? Yeah, read-only but lowercase. Because we don't want anyone messing with our bestiary once it's created, right? So here we're going to write select spawn random, and it's going to spawn a random animal from the bestiary, so it's going to return a mob that it wants to spawn. So what is it taking? A bestiary, which is a read-only array of mobs, and it's going to return a mob, right? Okay. Oh, is that how it works? We get a .js and a .d.ts. How's the TypeScript learning? It's going pretty well, I think. I'm almost done with this chapter. So we're going to be done with objects soon. Then we do type manipulation, whatever that is. Classes should be important, right? And then modules. So we're almost done. We almost know TypeScript, y'all. All right, so how do you get a random number in TypeScript? Math random. What does math random give you? Is that what MDM TypeScript? Or is it JavaScript? Is that what I want? And then do I look under, is there something like math? How do I find stuff? References. Probably here. So we find math. Then we have math random. Let's see. Static method returns a floating point pseudorandom that's greater than or equal to 0 and less than 1. So it's 0 to less than 1. So if we want to write this, then I guess we should make a random function, right? Assuming it's like up to n, and it returns number. So we take math.random. This is like between 0 and 1. Then we multiply this by n. No. How do we get like 1 to 3? Yeah, we want to multiply times 3 times 10. Is that right? Because if you are, basically I want the 1. Oh yeah, we want to multiply by 3, by like, so it's multiplied by n, right? So now the highest number is 0 to 3, and then not including 3, and then we will just floor it. Right? Is this it? Oh, you can pass a number into random? It doesn't say it takes in a number. There's no parameters for random. So how does that work? I'm confused. Alright, so here we are. Do I have any other console logs that I want to get rid of? Yeah, let's get rid of these. And we're gonna just try this out and see what our numbers look like. 1, 2, 1, 0, 2, 1, 0. So it is going to basically n minus 1, which is fine for an index array, right? So let's do that. We'll leave that here, and so we'll do like stop it. Random, and we get the length, which is bestiary dot length, right? And now we can return bestiary index like this, I think. Now let us check if we actually this is kind of bad because there are going to be 3 wills. We don't want 3 wills, right? That is going to be lame, so let's not do that. We won't know the difference. I can't type. Okay, that's the rabbit. And we'll also have a fox. You got no follow alert. Oh, did you follow? Oh, there you... Boskin. I don't know why we don't have follow alert. But, thanks for following.
You can define class to instantiate many types of wolf.
You mean like the class stuff here that we haven't gone to? We're not there yet. We're not there yet. So this is what I know how to do so far. We can also create a constructor, right? Make a function that does it. So either way, what I want to do is check how this read-only thing works. Here we're just accessing, so it should allow me to do it. I'm spawning it. So now what I should be able to do is console.log spawn random and pass it in the bestiary. I'm a developer. That's my current profession. And we will do this. So rabbit, wolf, fox. Whoops. Rabbit, rabbit, wolf, fox. So it is picking a random one out of all of them. And now let's try to change one of them. So we don't just return it right away. Here we're getting it. And then we do mob dot position is equal to. Is this gonna let me do this? I bet it's gonna let me do this. Yeah, because it's just caring that I'm not trying to change this. What it won't let me do is modify this to something else. This is going to be illegal, and it's going to say index signature only permits reading. So it's still the same thing where it kind of gives you some protection, but yeah, what are you saying? Class is a more formal way to create objects instead of using object literals. Get in the habit of always using const. Notice that their own examples often don't use const, right? Like they have let and all these things everywhere most of the time. But I guess I'll try. I'll try to use const. Although here it doesn't really change anything. It still lets me change stuff underneath, right? It's just kind of icky. But it does stop me from doing this. However, I guess like if I just changed it to be like, I wonder if it'll even let me do this. Does it let me shadow stuff? Duplicate. No, it doesn't. Bestiary 2. Value never used. Read-only mob is read-only can't be assigned to mutable mob. Oh, interesting. Alright, so the direct thing doesn't work that way, but you see I'm passing bestiary, which is read-only, but if I guess this will work. And that's what they were kind of saying in here. Yeah, there's no error here. Even though this was declared read-only array, we were able to basically say, no, we're actually getting an array here and change it. I'm not saying it sucks or anything. Oh, look at this. It's not assignable. It did check us here. So that's good. It did give us an error here. All right. Good going, JavaScript. They do use a a lot of lets where they don't need to. But we'll just see. We'll pay attention more and see how they go. But I will pay attention. Thank you. We did this. Okay, we got all this. We did this. One last thing to know is that unlike the read-only property modifier, assignability isn't bidirectional between regular array and read-only arrays. Yeah, I think we just did that too, sort of. Because this is the same as saying read-only and then the array thing. Tuple types. Alright, so tuple types is an array that knows exactly how many elements it is. So it's not like string bracket bracket, but it's bracket and then the element types within it. I love tuples.
I wonder why Restream doesn't have like follows anywhere. That's so annoying.
Here, string number pairs a tuple of type of string and number. Like read-only array, it has no representation at runtime, but is significant to TypeScript. To the type system, string number pair describes array whose 0 index is a string and whose 1 index contains a number. So here we're passing in a tuple, const a0, 1. Right, so it can derive the type. I like that. I really like tuples. If we try to index past the number of elements, we'll get an error. Awesome. We can also destructure tuples using JavaScript's array destructuring. Oh my god. Yeah, so we just put the names of the variables that we want to destructure to, and it pulls it out. So that means if I do so we say like position tuple, so we make a position, right? Yeah, I love them too. Position tuple, and then I pass in a function that says something like function move, and it takes in a position, and returns a new position tuple. We can just deconstruct this with x comma y, and now we can just return x plus 10 comma y, and then we can just do console.log lost. So if we're at 0, 0, we should end up at 10 comma 0, right? There we go. Yep, 10 comma 0. So that's cool. I love it. Tuple types are useful in heavily convention-based APIs where each element's meaning is obvious. Yes, I use tuples a lot. Elixir is all about the tuples. Other than those length checks, simple tuple types like these are equivalent to types which are versions of array S that declare properties for specific indices and that declare length with a numeric literal type. String number pair. Specialized properties. Length 2, 0. Oh, I see, I see. This is equivalent to a tuple of string number. Another thing you may be interested in is that tuples can have optional properties by writing out a question mark after an element's type. Optional tuple elements can only come at the end. That makes sense. And also affect the type of length. So here we have, it might be a 3D point or a 2D point. And so z is going to be number or undefined. We don't know. And then the length property can be 2 or 3. So if we had an extra one, why can't I run this? The fuck? Let's just do it here. So if I added an extra number for 40, then in here, this is going to be 2, 3, or 4. Yeah.
Wow, I didn't know you knew JavaScript destructuring assignment syntax. I guess you already learned about it.
No, I don't know. This syntax of destructuring is very common in functional languages, and those are the languages I know. So, like, that's how you work when you're doing like functional languages. So it just seemed like a good guess for me. It's just that's how it should kind of work. Yeah, when we do some more streams on Elixir or Haskell, you'll see a lot of what it's called pattern matching, and it kind of goes further than what you can do with TypeScript. Tuples can also have rest elements which have to be an array tuple type. All right, okay. String number booleans describes a tuple whose first two elements are string and number, respectively, but which may have any number of booleans following. So it's like you don't know how big it's going to be, right? The length of it. Chord.length. I wonder what it prints here for the length. It's just a number because it doesn't know. And if we got rid of this, it's 2, right? Okay. String booleans number describes a tuple's first element is a string, then any number of booleans and ending with a number. Okay, I get it. We get it. A tuple with a rest element has no set length. It only has a set of well-known elements in different positions. Yeah. Well, yeah, most JavaScript beginners maybe, but like, I'm definitely not a beginner programmer. I've been programming a while. Just very, very little JavaScript. Very, very little JavaScript. I would say JavaScript is one of my worst languages. Well, now, like, I know more, right? Because I've been learning it. But, like, I know Lua, it's probably around there where I've used it a little bit. Yeah, not very low on my language list. Why might optional and REST elements be useful? Well, it allows TypeScript to correspond tuples with parameter lists. Tuple types can be used in REST parameters and arguments so that the following, we have args, and we know the arg is going to start with a string, then a number, then a whole bunch of booleans. Name, version, and then a bunch of boolean inputs. That makes sense. Yeah, those two are the same. This is handy when you want to take a variable number of arguments with a REST parameter and you need a minimum number of elements, but you don't want to introduce intermediate variables. Read-only tuples. On a final note about tuple types have read-only variants and can be specified by sticking a read-only modifier in front of them, just like with the others. Yep, got it. I kind of wonder though. Okay, so what was I thinking? I was wondering, what is this say? Pair read. Okay, so it uses the same syntax that we use here. But we learned that arrays are basically like array functions, right? Like, I mean, like, they're kind of like, I wonder, can you say something like this? No? Oh, this is an array of tuples. That's what this is. I wonder, like, how tuples are actually, like, implemented in TypeScript. Yeah. Oh well, I was just curious. Right, so you can't change stuff if it's read-only is what they're saying here. Tuples tend to be created and left unmodified in most code, so annotating types as read-only tuples when possible is a good default. Yes. This is also important given that array literals with const assertions will be inferred with read-only tuple types. as const. What is this saying? La, 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 la. This is also important given that array literals with const assertions will be inferred with read-only tuple types. Okay, so this is a read-only tuple is what this is saying. That's kind of worth knowing because that I would not probably remember. Const assertion on tuple will make it read only. I think that's what it basically said. As const, so here we're passing in x and y, we're doing stuff. Point, distance from origin. Argument of type read only 3-4 is not assignable to parameter type number is read only. So here, this should be read only type, right? And then it works. Okay. Here, distance from never modifies elements but expects immutable tuple. Since points type was inferred as read only, it won't be compatible with number. Since that type can't guarantee points elements won't be mutated. Perfect. I get it. I understand.
We are good.
Yeah, all those tuple types disappear. But at least we get compile checks, right?
That's the important part. TypeScript has
Name tuples. We'll probably get to that.
So I think we'll end here. How long did we go for today? Is it short?
An hour and a half. We usually go 2 hours, but an hour and a half isn't bad. We'll do type manipulation next time. There's no main page for it. Creating types, short, generics, short, key of short, type of short, indexed short, conditional. Conditional types look a little bit longer. Map types is kind of long, not medium length. Template, literal types. So definitely we can do a whole bunch in the first session and maybe we do the last in the next. And then we do classes. Ooh, classes is a meaty one. A lot of stuff here. And then we do modules. And then we're done and we can call ourselves TypeScript experts. All right. Thanks everyone. I hope that was semi-useful to you guys. If you have any questions, feel free to comment if you're on YouTube or whatever, or join the Discord server. There should be a link in the bio, description, whatever. And we can talk there. Otherwise, I will see you guys soon, hopefully tomorrow. Have a good day. Bye.
Thanks for helping me out, Blastoderm.